This program was made possible by Wings Over the Rockies, educating and inspiring all people about aviation and space endeavors of the past, present, and the future. Hi, I'm Sean Sederberg, and this is Behind the Wings. In this episode, we'll take a look at the innovations in aviation firefighting.
Only you can prevent forest fires.
Wildfires have been increasing in frequency, intensity, and complexity all across the western United States and around the world. When the fire does new things, firefighting teams have to do new things too.
Anyone can start a fire and never even know it.
CalFire in California is one of the largest fire agencies in the world, with more than 60 aircraft and growing.
But every year we start forest fires.
Black Hawk helicopters are converted into Firehawks. Critical data is streamed live between aerial and ground crews, and night vision goggles allow pilots to fight fires from the sky at night. It's time to go behind the wings. While 2020 was unprecedented, wildfires have been intensifying for years. California aviation firefighters provide one of the best examples of how aviation programs can develop in response to the increasing fires.
My name is Stu Sprung, and I'm the Chief of Flight Operations for CalFire. So this is the CalFire Aviation program. We are the largest aerial firefighting fleet in the world. We provide aerial fire protection for the state of California and the 40 million citizens that are in it. Right now we're at about 60 aircraft that we staff throughout 22 bases throughout the state. And the mandate for those aircraft is to quickly respond. We respond them like we respond fire engines out of fire stations. Within 5 minutes, we try to get in them and out the door. We respond to those fires in our responsibility area within 20 minutes and keep 95% of them under 10 acres. Fire seasons used to be about 4 months, and that was accepted for many, many years in the fire service. And in the past several years, it's become more of a year-round experience for us. Our fleet certainly has expanded because of those increased needs. Anyone flying in an airline over the state can look down in the forest and see big swaths of dead trees. And really those just turn into kindling that just, if there's a fire or happens to be something nearby, they just go up instantly. So we have a lot of forests, we have a lot of trees, but we also have people that reside in those areas, right, and have homes and whatnot. All we can really do is saying, okay, the threat has changed. We have to grow with it and adapt to it. We're making the biggest jumps we can with the available equipment.
My name is Chief Benjamin Berman. I am the helicopter program manager for CalFire. There's definitely a demand signal for an aviation fleet of this size and expanding. About ready to onboard 7 brand new C-130s. We have 12 CalFire Hawks, S-70i CalFire Hawks. I think we've gone through unprecedented change in the last, I would say, 24 to 36 months on the rotary wing side. Going from a Type 2, we call it, which is the Huey, to a Type 1, which is the CalFire Hawk. Multi-engine, multi-system, lots of redundancy, twice as heavy, twice as large helicopter. We're definitely seeing more of a challenge, but I know that CalFire and our interagency partners, we're definitely stepping up to that challenge. 95% at 10 acres, those don't typically make the headlines, and that's something that is being done in the background.
With our aircraft in coordination with the ground crews, we get it done. It's that 5% that we can't catch, that's too big for us. That's when we rely heavily on contract aircraft. We have hundreds of operators and hundreds of helicopters and airplanes that we have available to bring in and help us with that. There's never enough resources, there's never enough data, there's never enough people to mitigate these where we'd like to. Obviously we wouldn't have the season like we did last year where we burned 4 million acres, where the worst season before that was 2 million, right? So in 1 year we doubled what our worst season was before. Our program's about 50 years old, and each of those years has provided us with education of how to improve our program the next, and continues to.
Events today are much more complex than they ever used to be. Decisions that we used to have hours or even days to make sometimes, are now having to be made in minutes. The better information they have, the better decisions they're able to make faster. We take data from different areas and different types of sources and information and pipe it into a super simple firefighter-friendly tool. It is entirely common now, especially with the size and scope of many of the wildfires that we have in the western United States, for any given one of them to have crews coming from dozens of states in the United States and internationally. And to be able to make it simple for those crews to see things is really the heart and soul of what we try to do at Intera. Started doing things with technology and imaging and being able to see things, fire perimeters and hyperspectral imaging, things we'd never been able to do before and provide intelligence to the fire service that we'd never really had. The big joke that most of them will tell you is that there's 100 years of tradition unimpeded by progress. I mean, we literally used to take an airplane up with a video camera and take a picture of the fire, and then you'd have to land and go take that videotape in and do something with it, and then those pictures, physical pictures, would end up back at the incident command tent 10, 12, sometimes 24 hours later. But the fire's no longer there, and so the intelligence wasn't as good as it could have been. We take that data in real time, take it right off the aircraft as it's flying and put it in the hands of the firefighters on the ground. It's one thing to have data in a spreadsheet. It's another thing to be able to understand what the data on the spreadsheet is telling you. So that's really what our engineers and our GIS people are really good at doing.
My name is Tom Eldar. I'm a software engineer at Intera. We take data and we present it in a much more user-friendly way. So what happens whenever a plane takes off to go to fight fires, take pictures, things like that? The moment it takes off, we get notice of it. We have a mission created on our end, and if they have a live video feed, they're able to open up the mission and see, oh hey, here's the live feed from that aircraft.
The firefighting industry has really glommed on to the technological advancements that have happened in this field. With a modernizing field, a lot of different technologies come into play. And as soon as you get all those different technologies working together, information turns into intelligence. If a fire chief shows up to a 1,000-acre fire, draws a polygon, and he can immediately notify the entire crew on the ground where the fire is at this point in time. When we put data on the map, we have to tell a story. And the story has to help the firefighters make the decisions on the ground that keep their community safe.
We have come leaps and bounds in just the last few years of being able to get information in near real time or real time into the hands of people who have to make decisions. And the reality is that we can do things today that we couldn't do even just a few years ago.
The firefighting industry is changing every day. New technologies provide new opportunities to both air and ground crews. Critically, fires don't stop burning at night. Agencies around the country are experimenting with night vision technology to enable them to fly at night. In Colorado, CalFire Aviation is leading the way with fixed-wing night vision firefighting.
Currently, there's really very little firefighting activity when the sun goes down. Now, sun goes down, we come home, get up the next morning, the sun comes up, we fight the fire. The fire doesn't quit at night. Now, we don't have to quit at night because of the night vision goggle technology. I first personally started flying with MVGs in 1982 in the Army in helicopters. And now it has kind of progressed into the fixed wing world with crop dusting, for example. The technology is there, it's been there, and it continues to refine. So we've got this highly technical apparatus here. This is just a standard light fixture, and we got a 7.5 watt bulb in here. So we make a little aperture, and what this does is simulate moonlight conditions. I'll show you the helmet setup and what we do. So the helmet has a power source. I can either power this side or this side, so that gives me redundancy. Essentially self-contained on the helmet. So the night vision goggle technology, you know, it goes back several years. So we're leveraging the equipment We're also leveraging the experience that we have, and now we're putting that into the ability to fight fires at night. Well, in the evening and the nighttime, you have less humidity. You actually have probably better aircraft performance because it's cooler generally, and you have less wind. We could take advantage of those situations by flying at night, having continuous coverage on the fire. We're on the 4th year of actually starting to do this. So we initiated in 2017, it was actually with the Oregon Department of Forestry. We would like to look into this. We know the technology's out there. We'd like to look into this. Would you be interested, CalFire? And CalFire said, yeah. We modified one of the airplanes because the cockpit needs to be modified to NVG compatibility. And so that's where we started in 2017, taking a look, putting a pilot in the airplane, flying it around. Can we do this? Can we safely drop retardant at night? Yes. Can we do it effectively? Yes. We are the first that is applying night vision goggle technology in fixed wing operations in night aerial firefighting, specifically the single engine air tankers. Now I'm looking through the goggles, but you can see I'm looking underneath. So the design of them, I'm looking underneath at the instrument panel, but outside I'm looking through the goggles. And it's very important for the cockpit to be what we call NVG compatible. So they're not having an influence on the goggles. That's why you see a lot there in the green light, because that is a spectrum of light that don't affect the goggles. And so they magnify the light.
For those of you that I haven't met, I'm Zachary Sullivan. I work for CalFire. I'm one of the pilots. I'm not one of the night vision pilots, so that's why I'm out here on the ground. So we run nine airplanes. One in Oregon's the only fixed wing aircraft out there on a night contract. We did it last year and they're gonna stand it up again this year. That kind of is the brainchild behind it. Basically what we wanted to do is invite everyone out, see what we're doing with it. First thing is I'd love any of your guys' feedback, like Sullivan, this just don't work. Or Sullivan, this, clean this up, or this is a good idea. So we know how to improve our program. And hopefully someday we'll start to see this technology put to use throughout either this state or neighboring states. We think it's coming, so we just want to make sure we have the best way of doing it out there. So the first airplane's taken off at 8:40, so that gives us about 20 minutes to get out there. The first drop will probably be coming at 8:50. So we'll have a little bit of daylight and then the rest will all be at dark. It's a brand new concept. Literally, the first place it's ever been done is in California with a couple of county agency helicopters. And that's been going on for about 3 years consistently. We stood up the airplane in Oregon last year for the first time, and we're the first fixed wing operator to ever do that. So it's brand new technology being implemented, and these things take time. It's we've taken the philosophy of a crawl, walk, run type of thing, and it just, implementation, you want to make sure it's done the right way. It's different because our target altitude is 60 to 80 feet from the fuel source. So again, that's not like a 747 that's flying at 30,000 feet. It's a little bit closer, so. There's always limitations. We can't just go out and fly through every amount of smoke in every situation, but it does give us, again, another advantage that we don't always have during the daytime. Another misconception is, wow, can you see power lines, cell towers, all these things out there that could cause an accident? You can see them better at night than you can during the day. Everything is so much better to see at night. So you've got a home, the fire's coming towards it. It's 8:52 p.m., which we have to be on the ground. With this technology, we can go a couple hours past that and go out and we can paint those houses. So maybe that will help save those houses where otherwise we can't fly. There's no chance, right? We're seeing things that we've never seen before. Well, that's why we brought this out. It's time, if the fire's gonna do things we are not used to, it's time to bring in ways to attack that fire that we're not used to, and this is one of those things.
While CalFire is leading the way with fixed-wing night vision goggle firefighting, helicopters are also an incredibly versatile tool in the aviation firefighting toolkit. Based on the famous Sikorsky Blackhawk, the Firehawk helicopter is modified to be one of the most capable firefighting aircraft available today.
My name is Eric Lama. I'm the Firehawk program manager here at United Rotorcraft. I'm in charge of all the current and future ongoing Firehawk programs that we have here at the facility. The Firehawk is a multi-mission helicopter, right? It has the capability of dropping and inserting firefighters, either at the front line or even at a fire break where they're dropping people off to go through and actually start to prepare the fire break. So what the Firehawk will do for the most part is they will transport the firemen and all their equipment out, drop them off, and then the aircraft will lift off and then go out and actually start taking on water, and then coming back and then work in conjunction with the firefighters on the ground, either to suppress the fire that's there or support them just in case something were to pop up where the firefighters needed to be removed from the area quickly.
Just watching what our customers are able to do with this. We have San Diego Fire, LA County Fire, who really helped drive the design of this. Now CalFire, Colorado. I mean, we're just really excited to see this platform entering into the market and doing what it's doing. LA County realized that the Huey just could not keep up pace with the increasing fires, with the fire intensity, but the technology just has advanced so much from the 1950s. And it was during those early designs, we're sketching, designs on the back of on a napkin, and Denton says, my son's got this monster truck. And if we took that design of the monster truck and we, jacked up the struts like that, we could do the same with the Blackhawk. That napkin and that monster truck idea is what drove the design of the Firehawk.
The aircraft has a 1,000-gallon water tank on it. And what that 1,000-gallon water tank brings is it allows the pilot or the crew to actually meter that water out of the tank itself. It can take on a minimum of 200 all the way up to the 1,000 gallons, and then actually use that and spread that out to help spread, a fire line. So this is the 1,000-gallon water tank. This is obviously mounted under the belly of the aircraft. This is the snorkel, 10-foot extendable and retractable snorkel here. The steps on the right-hand side of the aircraft for the crew to get in and out of the airframe. I can't think of a better testament than giving the Blackhawk to a group of 18, 19, 21-year-olds that are in the military and allowing them to basically go out and just use that aircraft and abuse that aircraft, and it comes back every day wanting more. It's on the ramp, it's ready to go the next morning. It's able to withstand a multitude of, I don't want to say abuse, but tough wear. Some of the other operators have commercial aircraft. They're not built as robust as what the Blackhawk is. That's what gives this Firehawk the capability to be able to go out there and land in rugged areas and to be able to do the mission that it does today. So, we have a multitude of different customers' aircraft in the hangar, and they do customize some of the different things, right? Different radios, different things, different equipment that they use specifically in their counties or their fire departments to help them communicate with their, their individual bases or the local police departments there. But the main thing for the Firehawk is obviously the high gear, right? We take the main landing gear off of the aircraft. We jack the aircraft up. We basically put a 20-inch extension there with the torque box, allowing the aircraft to be jacked up to be able to handle that 1,000-gallon water tank. And what the tank has is it has a 10-foot snorkel that's extended and retracted from the cockpit to allow them to fill that tank. The pump will actually suck 1,000 gallons of water into that tank in under a minute. They get the water as close as they can to those fires so that they don't have to make a bunch of trips back and forth. The tank itself has a 45-gallon foam tank mounted to the back of it that's also controlled via the cockpit, allowing pilots to inject firefighting foam coming from Sikorsky. It has the stroke attenuating seats for the crew to allow for crash impacts, so that the seats will absorb the impact. We've gotten it down to a point where we can paint that aircraft and have it completely modified in 8 months. The longer they sit here, they're not out fighting fires. They're not dropping firefighters into the hills. They're not out dropping water.
50% of all fires can be eliminated if they're put out within the first 20 to 30 minutes before they have a chance to grow into this big fire. And if you talk to LA County, they're going to say the Blackhawk basically, that is the only aircraft that give you that performance capability and allow you to fly in areas that no other helicopters can.
Helicopters like the Firehawk are undoubtedly valuable tools for aviation firefighting teams. But how do helicopters fly? Next, we'll hear from Camille Calabeo to find out exactly how helicopters take to the skies.
How do helicopters fly? Helicopters are very versatile aircraft. They can take off and land vertically, and they can hover, making them ideal for a variety of missions, including firefighting and search and rescue. But how do they work? Helicopters stay in the air thanks to their rotor blades, which work similarly to airplane wings. Both forms of aircraft generate lift when large amounts of air move over the wings or rotor blades very fast. When airplanes fly through the air travels around the wing to produce lift. When helicopters fly, the air travels around the quickly spinning rotor blades to produce lift. When rotor blades are spinning very fast, the body of the helicopter wants to spin in the opposite direction because of Newton's third law. To counteract this, most helicopters use another set of blades mounted sideways on the tail called a tail rotor. The tail rotor pushes the tail in the opposite direction of the torque induced by the main rotor, so the helicopter can fly in a straight line or maintain a stable hover. Lastly, helicopters control their movement by changing the angle and/or speed of the rotors. Helicopters' ability to navigate at slow speeds and even hover make them a critical piece of the aviation firefighting toolkit.
Wow, the technology used in aviation firefighting is super impressive, but it does come with a cost. As states and agencies consider greater investments in aviation firefighting, it's important to look at both the costs and the benefits.
The cost that's associated with, for instance, DFPC's Firehawk, the S70i that they're going to buy. You look at the initial cost, once it's all said and done outfitted, they're paying $24 million plus just to get that aircraft out the door, equipped and ready to go. Then you start looking at maintenance. Are they hiring within, or are they going to do, you look at CalFire, they hired within. But it's a multi-billion-dollar operation a year for maintenance. You're looking at a rotor aircraft, you have 1 million plus parts that are trying to get away from itself. Helicopters are probably the most maintenance intensive part of what we do firefighting versus our fixed wing.
As we go through that life cycle of an aircraft acquisition, there's definitely lessons that we learn almost on a daily basis. We're utilizing infrared, we're utilizing real-time mapping, we're utilizing a lot of these different technologies to help us with a better understanding of what tools to employ.
We have an acronym that we talk about C. It's got to be safe, effective, and efficient. And this aircraft fits all those requirements. It's safe because it's got 2 engines. It's effective if we use it right, it's the right tool, and we're learning that. We take all that information, we mold it to our model that CalFire uses, what other states might use from Washington to Arizona or Colorado. I'm sure they'll be looking at us, watching us, what we do, and they'll go, oh, that's probably a model that we may set up for them to follow in our footsteps.
At the end of the day, right, we had to make our own evaluation and look at what was going on out there. Everyone was like, these are game changers. They make a huge difference. And put out just one, and suddenly the Firehawk is well worth every penny. Colorado's in a place, now is the moment. We need to make these investments so that we are ready and we can protect Colorado's future.
Really excited about the progress Colorado is going to make thanks to the bill we'll be signing today and our legislators who are here today in being able to fight forest fires and hit them hard early.
We had the conversation, is it worth the $24 million investment to bring a Firehawk to this state? And I think we were convinced by the evidence we see in California. And I wouldn't be surprised if at some point in the next few years we're purchasing another Firehawk because we see such a dramatic improvement in our ability to respond early to wildfires.
Obviously from the fire season that we had last year, that brought a lot of attention to the Firehawk and to other firefighting apparatus capabilities within the state. And I mean, we had 2 of the largest forest fires in Colorado history last year. Had it not been as bad as it was that last year, it may not have gone through as quickly. It shows, that the legislators of Colorado are dedicated to its citizens. The future is kind of unlimited, right? I mean, it's kind of the old saying, right? If you can dream it, it can be done.
Reducing CO2 emissions and greenhouse gas emissions is something that needs to happen there is hope. This is not inevitable. When you can literally see, some of the effect in the sky, it has an impact. But I think a lot of us are also in this field are hopeful because we know that it is possible to change this trajectory.
Lightning is still going to strike in unknown places. But I think the effectiveness of what we're learning here and what we're doing can be measured. So I hope 5 years from now we have some data that says, look what we've done. Look how many lives we've saved. Look how many structures we've saved. Look how many fires we got put out in the first 24 hours, let's say, before they spread.
Firefighting is not going away. But how we do it and how effectively we do it and how safely we're able to do it is going to continue to change.
Wildfires won't stop burning, and aviation teams are pushing forward with new techniques to face the challenge. Today's aircraft are capable of delivering heavier loads at faster speeds with even more informed strategy. All of these tools will play a role in the next chapter of aviation firefighting.